Hello everyone. Today we are going to find the fixed end moments in this beam using column analogy method. In this beam there are 2 point loads 18 kN and 9 kN. The load 18 kN is acting at a distance of 2 meter from the point A. The load 9 kN is acting at a distance of 4 meter from the point A. The total length of the beam is 6 meter. We know that in this fixed beam, the degree of static indeterminacy is 2. To make this beam statically determinate, let us remove MA and MB. When we remove MA and MB, this fixed beam will become a simply supported beam. You can see that I have converted the fixed beam into a simply supported beam. Let us find the reactions RA and RB. Let us take moment about B and find RA. In this case, we have to use right hand side rule, clockwise positive and anti-clockwise negative. RA is acting in the clockwise direction, so that it will be positive and the distance is 6, so 6 RA. This load is acting in the anti-clockwise direction, so that it will be negative and the distance is 4. This load is also acting in the anti-clockwise direction, so it is also negative and the distance is 2. Finally, for RA, we are getting 15 kN. By applying the rule sigma V is equal to 0, we can find RB, which is 12 kN. Now let us draw the bending moment diagram for the simply supported beam. We know that in the points A and B, the bending moment will be 0. To get this ordinate, we have to multiply RA with the distance 2. 15 into 2, we will get 30. To get this ordinate, we have to multiply RB with the distance 2. 12 into 2, we will get 24. To find the area, I have split the diagram into 4 parts. We have 3 triangles and 1 rectangle. Let us find the area in the first part. This is a triangle. We know the formula for the area of a triangle, half into BH. Here B is 2 and H is 30. Let us apply in the formula so that for the area we will get 30. Let us find area 1 x1 bar. We know the area 30. We are going to find the centroid towards the point A. For this triangle, the centroid towards the left is 2 by 3 into B. Here B is 2, so 2 by 3 into 2. Finally, for area 1 x1 bar, we will get 40. Now let us take this triangle. We know the formula for the area, half into BH. Here breadth is 2. We have to find this height. 30 minus 24, we will get the height 6. So for the area, we are getting 6. Let us find area 2 x2 bar. We know the area 6. For this triangle, the centroidal distance towards the left is 1 by 3 into B. Here B is 2, so 1 by 3 into 2. But we are finding the centroidal distance in the point A. So we have to add the remaining distance. The remaining distance is 2 meter. So we have to add that. Finally, for area 2 x2 bar, we are getting 16. Now let us take the third part. It is a rectangle. We know the formula for the area of a rectangle, BH. Here the breadth is 2 and height is 24. 2 into 24, we will get 48. Let us find area 3 x bar 3. We have found the area 48. We know that in the rectangle, the centroid lies in the center. So to get this distance, we have to divide 2 by 2. Then we have to add the remaining distance, that is 2. Finally, for area 3 x bar 3, we will get 144. Now let us take the fourth part. This is a triangle. We know the formula for the area of a triangle, half into BH. Here the breadth is 2 and height is 24. Finally, for the area, we are getting 24. Let us find the area for x bar 4. We have found the area 24. For this triangle, the centroid towards the left is 1 by 3 into b. Here the breadth is 2. So 1 by 3 into 2. Then we have to add the remaining distance. The remaining distance is 2 plus 2. We will get 4. Finally, for area 4 x bar 4, we are getting 112. We know that in the column analogy method, we have to find the resultant P. Resultant P is the total area. We have to add all of the areas. After adding, we are getting 108. Now let us find Px bar. For that, we have to add all of the moment areas. After adding, we are getting 312. We have found P and Px bar. To find x bar, we have to divide P by Px bar. When we do that, we will get 2.889 meter. Now let us make the analogous column. We know that the cross section of the analogous column is 1 upon EI into L. We know that length of the beam is 6 meter. We know that P is the resultant. The resultant acts at the distance of 2.889 meter from the left. We know the formula to find the stress in the base of the analogous column. P upon A plus or minus PEXA upon IY. To find the stress in the point A, we have to only take the positive sign from the formula. And to find the stress in the point B, we have to only take the negative sign from the formula. Let us find the eccentricity E. We know that the center of the analogous column lies at the distance of 3 meter from the left. It is the eccentricity. We know this distance 2.889 meter. So the eccentricity E is equal to 3 minus 2.889. We will get 0.111 meter. Now let us find the moment of inertia. We know the formula to find the moment of inertia. I is equal to BD cube upon 12. Here B is 1 upon EI and D is 6. But no need to consider EI. When we apply the values inside the formula, we will get 18. Now let us find the cross-sectional area of the analogous column. That is 1 into 6. We will get 6. Now let us find XA. XA is the distance from the center to the point A. We know that this distance is 6 by 2, so that we will get 3 meter. In this formula, we have found everything. Let us apply all of them. We know that for MIA, we have to select the positive sign. 18 plus 2, we will get 20. For MIB, we have to only select the negative sign. 18 minus 2, we will get 16. We have found MIA and MIB. Now let us find MSA and MSB. To find MSA and MSB, we have to look at the bending moment diagram. In the point A, the bending moment is 0, so MSA will be 0. In the point B also, the bending moment is 0, so MSB also will be 0. Let us find MA. The formula is MSA minus MIA. We have found MIA and MSA. Let us apply both of them. Finally, for MA, we will get minus 20 kilonewton meter. Let us find MB. The formula is MSB minus MIB. We have found MIB and MSB. Let us apply both of them. Finally, for MB, we will get minus 16 kilonewton meter. For MA and MB, we have got negative values. That means both of them are hogging moments. Now we are going to end this session. Thank you for watching this video.